Hey everyone, welcome back to my YouTube channel. Let's code together. Today we are diving into the observer design pattern, one of the most widely used behavioral design patterns in software development. If you are ever wondered how systems update multiple components automatically when something changes, so this video is for you. The observer design pattern is one of the behavioral design patterns. It establishes a one-to-many relationship between objects. So you can see in this diagram, so multiple objects called observers, they are associated with a single object, that is subject. This pattern allows subject to notify its dependents whenever its state changes without them being tightly coupled. In other words, we can say, so whenever there would be some change on the state of this subject object, right? So these observer objects will be notified and they can further perform the action based on that change in the subject. So let's take real world example. Imagine you are following your favorite tech YouTube channel like Let's Code Together. So whenever I upload a new video, you get notified immediately, right? In this case, YouTube is a subject and you, the subscriber, are the observers. Whenever the subject changes, such as new video is uploaded, YouTube automatically notifies all the subscribers, right? So these green icons, these are the subscribers. So whenever there is a change in the YouTube channel, so for example, new video is uploaded on this channel, the subscribers always get notification, and on the basis of this notification, subscribers can perform further action, whether they want to watch the video or decline the video. But the users of YouTube which are not the subscribers of this channel, they will not be getting any notification. So this is the real world scenario. So let's discuss the components of observer design pattern. So there are basically 4 components of this pattern. First one is subject. So subject defines methods for attaching, detaching and notifying observers, and it holds the state that changes and triggers notifications. So basically this subject would be an interface. So where we will be defining some common methods which further concrete class will be implementing. Similarly, we have another component, observer interface. So it defines an interface for receiving updates from the subject. So whenever there would be some changes coming from the subject, so this observer will be taking care of the notifications coming from the subject and it will be performing further action. So in observer pattern, we always have a update method to react on the state changes in subject. The third component is concrete subject. So concrete subject is the implementation of subject interface. So whenever there will be some state change, so this concrete subject will be responsible to notify all the observers. And the last component, we have concrete observer. So that is the implementation of observer interface. So it updates its state based on the changes in the subject. So as I mentioned in the previous slide, so whenever there will be some state change in the subject, so this class will be taking care like what to perform on the state change in the subject. So the update method that is coming from the observer interface. So by using that method, so this concrete observer will be reacting on those changes that are coming from subject. So you can see in the diagram, so subject and observer are the interfaces. The concrete subject and concrete observer, those are the implementation of respective interfaces. So let's break it down into the software problem. Suppose we are developing a stock market application. We have a stock price tracker and multiple users want to be notified when a particular stock's price changes. So we can't hard code every user's notification logic into the stock tracker, right? So that's where the observer pattern comes in. It helps us design a flexible system where the stock price tracker is independent of user notification logic. Let's jump into the code to understand how to implement this pattern. So let's create our first interface, observer. And in this interface, we have a method void update, and it will be accepting one argument of double type, that is price. So we need to make this interface. So let's create another interface, that is subject, and let's make it interface. We have 3 methods, void register observer. Second method is remove observer, and third one is notify observers. So as per this diagram, so we have observer interface, which has one method update. So we have subject interface where we are defining the methods for attaching, detaching and notifying observers. So in our case, the names are a register observer, remove observer and notify observer, right? Now we will be creating the concrete classes for these interfaces. So let's create our subject concrete class. So let's name it stock price tracker. So this will be the implementation of our subject interface, and we need to override the interface methods. So register, remove and notify, and along with that, so we have one property that is list of observers, right? Here let me import util package, and we can initialize this list right away, new array list. And we have another property, private double price, right? And these methods, register observer means we need to add our subscribers or observers in this list, right? So whenever this function will be called, we will be passing the observer in this method, and finally we will be adding that observer into this array list. So basically stock price tracker will be keeping the references of all the subscribers, and as per requirement, if we need to unsubscribe any of the observer, so we have this method, so we can remove this observer from this list. And if we want to notify the subscribers or observers, let's write a for loop that will be traversing this list of subscribers, and we will be calling the observer dot update method, and we can pass the price, so that that price will be sent to the observer. So we can say this is the property whose changes we are tracking, and we will be sending the corresponding notification to the observers. Moreover, in this class we can have one method, one setter method for changing the price. So this is our subject class. So in this diagram, you can see we already mentioned, so all these observers are associated with this subject. So the same replication we have done in our coding. So we are talking about this list. So let's create our observer class. So let's call it user, and this will be the implementation of observer, and we need to override the method update. And whenever this method will be called, so I am just printing here. Before printing, let's add one property here. So private string name, and let me create the constructor for this and initialize the name here. Whenever there is some update, so we will be writing our business logic. So as of now we are just printing, so the name got notified and new prices, whatever the price we got in this method, right? So as per this diagram, so now we have created concrete observer, so that is user in our case. So that implements the observer interface, update its state based on the change in the subject, right? So whenever there is a change on price in the subject, so you can see we are calling the update method, right? So, and the reaction from this observer class is, as of now we are just printing, but we can write any business logic on that change, right? Now one thing we need to do, so when this notify observer method will be called, so whenever there will be a change on price, so we need to call notify observers, right? So this is the implementation of observer design pattern. So let's create the client program. So let me create one main class, and we have main method here, and let's create some observers. Observer user1 equals to new user Parvinder, observer2, and let's create another user. So we have created 3 users, and to get the notifications we need to register it with our subject. So let's create the object of our stock price tracker. So stock price tracker dot register user1, and similarly we can register all our users or all our observers. Now at some point, for example, stock price tracker dot set price, so some value is changed. So let's pass, for example, 34.56, right? And if I run this program, so in output you can see Parvinder got notified, Mike got notified, and similarly John got notified with the latest price, right? So whatever the users are subscribed with that subject, they got notification. Now here all observers user 1, 2 and 3 are subscribed with that subject. That's why they got the notification. So let's think like we have some other logic here, right? So this is just the dummy logic, and at some point user 3 wants to unsubscribe. So stock price tracker dot remove observer. For example, user 3 got unsubscribed. So then later there is a change in the price again. For example, it's 10.50, right? Let me run this program again because there is a change. So the user should be notified. So in the output, you can see previously there were the notification for 3 users. Now the notification is for 2 users only, because now only 2 users are subscribed with this channel. So this way we can implement the observer design pattern. So this is the class diagram. We have subject interface with these 3 methods: register, remove and notify. And the implementation of the subject is stock price tracker. So where we have added the list of observers and the price property and the implementation of subject methods. Similarly, we have observer interface, and the implementation of observer interface is the user class, where we have added additional property name, and we have overridden the method update, which receives the notification. And in this update method, so we can write any business logic that we want to perform on the basis of change in the price from stock price tracker. And this is our client code. We have seen right away how we have added the observers into stock price tracker and get the notification when there was a change on the price. So this is all about observer design pattern. So the observer design pattern is incredibly useful in the situations where multiple objects need to stay updated with the changes of a single object, right? If you found this video helpful, don't forget to like and subscribe to Let's Code Together. Also hit the bell icon so you can be notified whenever I upload new content. Thanks for watching and happy coding.